Hi, I'm Sai Vikas, bearing ID number 47542705. This big data assignment 3. This below here we can see the first code, like we are importing the pandas, and then from there, like we are loading the data sets in it with the p read paraquat and of different months like Jan, March, and June, and displaying few rows, and this often displays the first few rows of the set time month in it. Below you can see here the trip volume, like the trip volume comparisons in the graph. Like first we're gonna import them, and there we can see the data preparation, like uh, it contains different kinds of months like Jan, March, and Feb, and then the trip volume of different months. And then we do create a good pie chart, where I had a different colors for that, for labeling it perfectly. And then the trip volume comparison, and it's equal, like this pie chart is usually comparing the trip volumes of different months. Each slice of in this average trip distance of that, here we, in the data preparation, we take average distances of different months, and then we create a bar plot where we can see x is represented as months, y is represented as average distance, and palette is where this. And from that palette type, we're gonna tell the title, and then we're gonna label that, and then we're gonna show the display of the bar plot that is shown on the screen. That's added, like there are different colors to it, which adds a visually good touch of the plot. In this you can see payment type distribution, where we can see the data that code comments explains the different kinds of payment coded as different kinds of numbers, where it counts the value, and then the payment types of different months like January, March, or June. It gonna create a data frame, and plot as a line graph, and from there we plot with different kinds of title, label, and thing. And this code also visualizes the distributions of taxi trips in New York City over time across 3 different months. This allows you to see how it gonna proportion the different kinds of payment of different kinds of months. In this data explanation pre-processing, we can check the missing values of different January, for example, January 23 data set, and in that we can display the columns with missing values and their different counts. And from there we can also see result in the second line that displayed of the columns of the missing value that represents different count. And also we can identify different columns that have noisy values, where the summary for the 23 dataset is displayed below, where you can see the different kinds of vendor ID, date time, extra tax amount, and everything of the taxis. And we can also see the fare amount, tip amount differently. And it also creates a criteria, and below you can see the criteria for noisy values, where it determines the fare amount of that. It shows the tip amount, and different kinds of surcharges to the airport. In that you can see the noisy counts, where we count each value for each column. And from that below you can see that we had the assumed data frame, like for example January, and then we have imported and then we have correlation matrix for the January 23 data set, where we can identify the pairs of columns with higher correlation, and iterate over the upper triangle. And from that you can also see a heat map of this correlation matrix, where you can see we have plotted everything that are in the correlation matrix of the January data set. where it contains everything in x and y axis. And below that we can see the data time format. In the below you can see the date time format where it, for example, in January month we can see the pickup data time, its hour, its day, and below that you can see the rush hours of it, and below that you can see number of hours and number of rush hours, non-rush hours, where we have showed in a pie chart. And below that we can see like in January month 71,982 trips are done in rush hours, and 2275 or 96 trips were done in non-rush hours. Here you can see the load of the taxi zone shapefile, where the taxi zone centroid, where we create a plot of the taxi zones and then the centroid, and you can see the taxi zones with in the form of centroids. And you can see we have plotted it below, like the taxi zones with the centroids. And below that you can see we compute the straight line distance and then trip complexity future. In this we can see we computed a straight line distance, and below that you can see the trip complexity future, where the map where the centroids of the data frame based on the pickup and drop off zones of different kinds of id. And below that you can see the straight line distance, and you can see the pickup and drop off frequencies of different locations, like it's I mean it we grabbed from the data set, you can see in the below. And we rank these vendors by popularity in data analysis, which is in the next task. So in this task we also have